Okay, so let me go ahead and do a video of the applications of quadratics. Let me pull up the sheet. Okay, so we did a little bit of this in class, but we kind of rushed it there at the end, so I just want to kind of go through it again. So what's going on is we have an arrow, and we have a formula that represents the path of that arrow. And so it's going to be shot from 5 feet off the ground. You didn't know that, but that's what that is. And then it's going to hit the ground at some point, okay? Now, this is what we're looking for part B. We want to know, where does the arrow hit the ground? For part A, it's asking us what's the height of the arrow when it is 10 feet. And this really should have said maybe something a little more clear, like horizontally from where it was shot. And so it's like, if we're out here at 10 feet, how high is this? So if this is 10 horizontally, then what's that? That's part A. Part B wants to know this. Where did it hit the ground? Okay. So part A is really just an order of operations problem. You're just going to plug it in and carefully keep track of the zeros that are between the decimal and the significant digit. Okay. Plug in the 10 because it's the number of feet horizontally. So that means that's going to be your X. So we're plugging it in where X is. This is 20 plus 5. This right here is 100. You can type it in on your calculator and do all that. But the numbers are kind of nice on this. Then 100 there would move this 2 places. It'd be negative 0.5 plus 25. That would equal 24.5. And the units on this were feet. Okay. Now part B is a lot more interesting. See, part B is wanting to know this. When does the arrow hit the ground? Okay, and it wants to know how far horizontally does it travel before it hits the ground. So it wants to know this. Okay, that's what it's looking for. That right there, that's part B. Okay, so when you see hit the ground, you should be thinking the height is 0, the y is 0. So we've got to solve this. When does that wind up being equal to 0? Okay, so we're going to go ahead and we're going to let A equal the negative 0.005, B is 2, C is 5. We'll go ahead and plug into the formula. C is 5 all over 2 times A. Okay, so I've just had to think while I was plugging it in so I didn't mess up. All right, and then I'm going to use my calculator to double check the things we did in a hurry in class. So down here, that would be 10. Okay, so it'd be 0.01 negative in the denominator. All right, on top, I have a 4, and see how we had 2 minuses, so that made it plus something. And then let me do the 20. Let me take that 20 times 0.005 and make sure that's done correctly. So that's plus 0.1. Let's see if I can erase those just a little bit. Maybe erase the whole thing. So hang on, let me get that rewritten. All right. So this actually turns out to be negative 2 plus or minus square root of 4.1. I think we might have had an extra 0 in there in class. All right. So that turns out to, and I've not rounded yet, but I'm about to do the square root of the 4.1. And that turns out to be about 2.025. So I'm going to put a little about symbol here. And that's 2.025. I'd like to keep a little more accuracy than maybe necessary until I get near the end. All right, so now I'm going to separate it into the plus part and the minus part and do those calculations. Okay, I'm going to move up here if you can follow along. Okay, I'm going to do negative 2 plus the 2.025 divided by the negative 0.01. Then I'm going to look at negative 2 minus 2.025 over negative 0.01, okay? And see what I get for those two. Turns out, it looks to me like this first one here, so we're moving up here. It looks like that first one's not going to be a reasonable answer because that, or the answer I'm looking for, because that turns out to be a positive on top and a negative on the bottom, which would wind up being a negative number. You know, if you wanted to, just for completeness, see what it turned out to be, it would turn out to be a negative 2.5. So it's going to travel negative 2.5 feet before it hits the ground. Okay. All right, let me show you where that's actually in this drawing. That negative 2.5 is actually what would happen if I extended that parabola until it hit the x-axis. That right there would have been the negative 2.5. So not really sensible in this problem situation. So we'll rule that one out. Okay. But if I do the other one, I'm going to get a negative 4.025 divided by a negative 0.01. So I can move those decimal places. This will become positive, which I'm glad about, and I'll have positive 402.5. Now it would have been, let's see if I kept more accuracy. Go back a little bit to see what it was when I did that. There it is. Nope. Okay. Anyway, let me just finish this. So that would turn out to be positive 402.5. It may be, it wants us to round to the nearest foot. So it may be if I had kept more accuracy here, like gone out further, that I would have rounded that to 402. But the way I've got it here, it looks like it's around 403. So I'm just going to say that. But if I had kept more accuracy, maybe 402 would be more appropriate. Okay. All right. So that would be this value. And I'm just saying it's about 403 feet. I don't want to go back and check the accuracy on that 2.025. But I might as well just to be correct. Okay, so if I really did it, that 2.025, that's really 2.02484. So if I kept it out more and I added the 2 to it, I'd have 4.024, 402.484. So really, I guess 402 would be more appropriate. But it should take either of those, really. Okay. All right. So the first question was just plugging in and simplifying the expression. The second part was actually going in, okay, and working out something similar to the quadratic formula, doing the quadratic formula type. Okay. All right, so let's look at another one. So this one is very similar, except for we have a baseball. I don't know why that's doing that. So this is 402 feet. Okay, I don't want it to move when I move the sheet. So let me try this again. Give it a moment. All right, so let's take a look. Okay, I'm just going to get rid of that, not worry about it. Okay, so the second problem says a baseball is hit at a point 3 feet above the ground, tells you the speed and the angle. So you can imagine this, though. A lot of you are very familiar with baseball. So we're going to have it still being a parabola. It starts at 3 feet. It's hit up in the air at a 45-degree angle. It's going to then follow that parabolic path to the ground. And they've already done the hard part. They've already used all of this information. You don't have to do anything with it. It's all tied into that formula right there. And so just like the arrow, X is the horizontal distance from home plate, and Y is the height of the ball in feet. So it says, how far from home plate does the ball hit the ground? So they're talking about this horizontal distance from here to here. Okay, we want to know what that is. Okay. And so that means we want to know, again, we want to know where the y would equal 0. Okay? So we're going to take, oops, I don't need the y. We're going to take, it's not letting me erase. I think it's got a whole lot of stuff it's trying to calculate right now. I got a lot of things open. We're going to take this and we're going to set it equal to 0 and work that out. Okay? All right. Erase. Try again. There we go. All right. So whenever you're doing one of these application problems, I don't usually even try to factor. I just plug in. I see my A. My B is an understood 1. My C is 3. So I'm going to do -1 plus or minus square root of the 1 squared minus 4 times the A, which is tricky. Don't lose those zeros. So -4 times -0.0032 times the C, which is 3, all divided by 2 times that -0.0032. Okay? So you've got this sheet. I would go ahead and take notes on it. You know this is -1. You know this down here is just 0.0032 times 2, but it's negative. So it's -0.0064. Okay. Then here we have plus or minus square root of, and the 1 squared is 1. We have this negative and that negative. So that'll be plus something. And then I'm just doing 4 times 3 times 0.0032 and getting that value. It turns out to be 0.00, nope, 0.0, not 00, just 0.0384. Okay. All right, so in there, do you see how that's really just 1.08384? 1 plus or minus square root of 1.0384, all divided by this -0.0064. Make sure that goes all the way underneath. So do the square root of the 1.0384. Okay. When you do, this turns out to be -1 plus or minus the square root of this right here turned out to be 1.0190. I'm going to keep more accuracy than you might think we need. And then -0.0064. Okay. All right. So I'm going to separate out the two things. But if I do, the plus one isn't going to really work, just like before. Okay, because when I do -1 plus the 1.0190, see how that'll be positive on top, negative on the bottom. That'll be a negative number. It's actually would be giving me this spot right here, where it would have, if it was there, where it would have hit to the left in the negative direction. Of course, that doesn't make sense. We want that spot. So we want -1 minus 1.0190 over the negative number on the bottom. Okay, so I'm going to do that. I'm going to do -1 minus 1.0190. And then that's a -2.019. Okay. So -2.019. Okay. All divided by a negative of all of that. Okay. All right. So I'm going to divide that by -0.0064. All right. When I do, this right here turns out to be around 315.4687. It said round to what? Didn't really say. We'll do like we did before and round to the nearest foot. So this would be around, this one right here would be around 315 feet. right there would happen at about 315 feet. Okay. Now, part B is kind of interesting. Right? Part B says, will the baseball clear a 20-foot high fence located 280 feet from home plate? Now that I've done part A, you see how it takes all the way to 315 to hit the ground? So what I need to know is if I was back here a little bit, okay, at 280 here, would the ball go over a 20-foot fence or would it hit it? Like, I don't really know how to draw this yet because I don't know whether the ball's going to hit the fence and bounce back onto the field or whether it's going to clear it. So that's what we're looking for. Okay. Probably the thing that would make the most sense or be the easiest to think about is to remember that this is the path of the baseball. So if I put 280 in here, so if the fence is out 280 feet, I could put 280 in for all the X's and then type that into my calculator to get about what that is. And I'm literally going to just type all that in. So I'm putting in negative 0.0032 times 280 squared plus 280 plus 3. And I wind up getting about 32.12 feet. Okay, now think about this. So, we had our ball going like that, hitting the ground out here at 315 feet. We're back at 280. And when we're back at 280, the ball, we know, is this height. The height of the ball is 32.12 feet. So the fence, we now have a better idea. The fence is only 20 feet high. That ball's going to clear it. So yes, the ball will clear the fence. Home run. Okay. All right, so those two problems were very similar. Let's take a look at another one where you're given a model. So this one has the rocket. Says its distance in feet from the ground in t seconds is given by that. This is not the path of the rocket. This rocket looks like it was just shot straight into the air, but the model does give its height after so many seconds. So the picture I'm going to draw is not the path the rocket took. This is just after 1 second, how high is it? After 2 seconds, how high is it? So this is the distance in feet above the ground. Might call it the height of the rocket. Okay, so that rocket's getting shot from the ground. It's going to go an increase in height. It's going to go up as time goes on, and then it's going to come back down. Okay, this one says, at what times will the rocket be 550 feet from the ground? So we don't want to know when does it hit the ground. How long does it take to hit the ground? We want to know when is it going to be 550 feet from the ground. Okay, so we don't know. Maybe it never is going to reach that height. We don't know, but we're kind of thinking this, that the rocket's going to go up and hit 550 on the way up, and then it's going to turn around, come back down, and hit 550 on the way down. Okay. All right. So let's think about that then. In this model, t is the seconds. And then this s of t, you can think of it as just an s. That's a function. That's the height that the rocket is above the ground, the distance it is above the ground. So think of the y-axis as being your s. So you're looking for really, when is this right here going to equal 550? When is it going to be 550 feet above the ground? Okay, so that's the initial part. Now, you should pause the video right here and work this out. It might factor, but you might just use the quadratic formula. Okay, and just work it out, see what you get for t, and then we'll compare our answers. So I would pause the video and work that out right now, and then come back and we'll see how you did. Okay. All right, so you're back now watching the rest of the video. So I would bring that 550 over, so I'm going to subtract it from both sides. Now I did notice that all of these were even, so I might take some time to cut the numbers down in size, really, if I were doing it. But you don't really notice that typically, and you don't have to do that. So I'm going to put in opposite of b. I'm going to put in my b and square it. I'm going to take away 4 times the a and the c, which are both negative numbers. And I'm going to divide that by 2 times the a. Lots of negatives, lots of room for mistakes, so be careful. And now we're just kind of going through the ropes. So I got a negative 32 on the bottom. Under the radical, the 208 has to get squared. Okay. I'm going to go ahead and put those in there. So that's 43,264. I have 1, 2, 3 negatives. So I'm going to have a negative, a minus here. I'm going to take 4 times 16 times 550, and that gives me 35,200. Okay. So I'm going to have negative 208 plus or minus the square root of, this would be 864. I don't recognize that as a perfect square, but I need to go ahead, and I'm not going to do factor trees and that kind of thing. These are application problems. We might as well just round off. Go ahead and find that square root. So what is the square root of 8? Square root of 8,064. Okay, it's not a perfect square. If I did it, it would turn out to be around 89.8. I'm going to keep a little accuracy on that, about 89.8. Okay. Just double checking that I typed things in right. I always like to double check before I go on. I want to make sure that number's correct, and then I want to make sure when I do the square root of that I get 89.8. Okay. And so now I have negative 208 plus or minus 89.8 over negative 32. And I'm going to do the two possibilities. Negative 208 plus that and negative 208 minus that. Okay. Either way, these are going to work because they'll turn into positive numbers once I'm finished. See, this is going to be negative 118.2 over negative 32. And so that's like 3.7 if I round it to the nearest tenth. And this one's going to be negative also 89.8, negative 297.8 over negative 32. And that turns out to be about 9.3 if I round to the nearest tenth. So let's kind of recap that. Let me squeeze that just a little bit so you can see the original problem. Okay, so we were originally trying to find out at what time the rocket will be 550 feet from the ground, so reach a certain height here. What we just found is it's going to hit the ground at this time and over here at that time. So one of them is like 3.7 seconds, and the other one right here is the 9.3 seconds. Okay, so those were would be the times the rocket would be 550 feet from the ground. Okay, so go ahead and check your work, see if we have the same answer. Okay, also never be afraid to let me know if you got something different or if you don't think I did it right. I don't mind checking. I can make mistakes too. All right, one more problem. That's kind of, well, two more, but they're related. So on 47, it says this is a formula that tells us the distance a car that's going around 68 miles per hour, the distance it will skid in T seconds. So if you're going 68 miles per hour and you jam on your brake, after 1 second, this would be the distance you would have gone. After 2 seconds, you could plug in a 2 to find that out. All right. The question was, find the time it would take for the car to skid 180 feet. Okay, so the T is the seconds. We want to know, when will this equal 180? Okay. And the only difference between that one and 48 is how long would it take for that to equal 500 feet. Okay. All right, the video is getting kind of long, so I think I'll just stop it and let you finish that up, and then we'll compare answers next time we get together. So you would just get them equal to 0, use the quadratic, and just see how that all turns out. So let me go ahead and stop this video.